From Purdue University in West Lafayette, Indiana, this is Techies Today, the Purdue Polytechnic podcast. I'm John O. Gozdem Kilaz is an assistant professor of engineering technology, and her research focuses on the development of alternative liquid fuels for transportation, specifically biofuels for aviation. She talked with us about her work on a project to convert plastic waste into jet fuel and other products, and Gozdem also has big news to share about an upcoming project. So Gozdem, you studied chemical engineering in Istanbul, Turkey, as well as here at Purdue, finally finishing your PhD here at Purdue in 2003.
Yes.
But I'd like to go back to Gozdem as a teenager. What first sparked your interest in science and technology and engineering?
That's an excellent question, actually, because in the very early stages of my school years, I had trouble reading. I was one of the last students in the class that could read, but math always was so enjoyable to me. I could understand the language of math better than the words. So I started gaining more and more interest the more successful I got throughout my years in high school, and my teachers always encouraged me to follow my heart, which my heart always was in science and math. So that's how I started getting interested in a career that involves math and science more than social sciences.
So you did a couple of years of postdoctoral research in mechanical engineering technology. How did you apply your background in chemical engineering to mechanical engineering? I imagine that there's some very significant differences in the fields.
Absolutely, and that's an excellent question, John, because nowadays we are always advancing technology and science at interface. We always have these multidisciplinary projects. So what I did is, instead of seeing my chemical engineering as a difference, I used it as an advantage to be able to see how we can make a synthesis utilizing the main principles of mechanical engineering, main principles of chemical engineering, and later on I started collaborating with materials engineering and chemistry as well. So many of the basic engineering principles are very common, and the differences always acted as an embellishment, as an advantage in my research, thankfully.
So it sounds to me like blending the two disciplines, chemical engineering, mechanical engineering, made you uniquely qualified for what has become one of your research specialties, which is your focus on alternative fuels for transportation.
Yes, that is correct.
Could you try to give us a layperson's explanation? What does it mean to be an alternative fuel? What's different about it?
So what is different is multiple things, basically. One thing is, environmentally speaking, if we are utilizing alternative fuels, we are not toxicating the environment as much as the petroleum-derived derivatives. And another thing that is so important is the resources are never going to diminish. They're never going to end. We can always raise biomass, we can always raise plants, we can just go ahead and cultivate, use this biomass towards the energy use. And another perspective of it is that in terms of the greenhouse gas emissions, imagine this. I always say that, John, to my students. Plants use carbon dioxide as their food for photosynthesis, and the aircraft and all the vehicles produce carbon dioxide, which is a greenhouse gas emission at the end of the combustion cycle after using the fuel. So imagine a closed cycle where we are producing a lot of carbon dioxide, which is a greenhouse gas emission, which is really bad for our future, for our environment. But the plants are already there taking this in. So at the end of the day, we are staying at a carbon neutral growth, which is the optimal solution for any environmental engineer and scientist. So this is the most attractive part of my research, that if we can be successful, we can leave cleaner, more responsible, sustainable futures to our young people to next generations.
Sustainability has
Sustainability is a
yes.
very important perspective of it, yes.
How did your research into alternative fuels grown from biomass end up with a focus on aviation fuels?
Well, aviation, in my opinion, is one of the most amazing and attractive industry, because the more global the world becomes, the more the aviation transportation is going to gain interest and momentum. So another perspective is, I hadn't been so aware of it before I got to work in so much close proximity to aviation, is that the emissions that we're producing at the end of an aircraft combustion are at such a high altitude that they are producing these emissions, these greenhouse gases, at an altitude that is unlike any other transportation vehicles. So trying to tackle such a unique but such a vast problem is an imminent issue that I wanted to get very much so involved in. And another perspective of the aviation that I really love is all the transportation fuels that are liquid transportation fuels give us only the energy when you're thinking about the ground vehicles. But for the aviation, they are utilized as the hydraulic fluid and the cooling medium. So they come into parts of every pieces that the aircraft has almost. So
they come into contact with
a lot of materials that the aircraft has. Okay. And because of this, aviation fuels are a different category on their own, because there is a lot of caution, there is a lot of fear associated with approving a candidate alternative aviation fuel. So the process is much more demanding, it is much more cumbersome and effort and money requiring that. I thought if we need to tackle one specific subject in terms of liquid transportation fuels, it needs to be aviation fuels. So that is my priority currently.
So Gozdem, you established a new lab here at Purdue, the Fuel Laboratory of Renewable Energy. Mm-hmm. Why did you need to establish this lab? What's unique about it?
We had to establish this lab, John, because there is no other lab at Purdue that is specifically focusing on the alternative liquid transportation fuels from cradle to grave. So what I mean by that is we try to understand the chemical composition of every liquid transportation fuel, which is a novel study, which is a novel approach, and then we're trying to correlate this specific chemistry to the properties, which is a focus area for many researchers in alternative aviation fuels right now, especially. So we do have a lot of incredibly valuable labs at Purdue, but as a Polytechnic member, I wanted to bring the youth-inspired research to everyday life, not only for the researchers, for the chosen ones, if you will, the graduate students, but I would like to make sure that all our undergraduate students get this opportunity to come into the lab, to be able to get their feet wet, if you will, to understand how the research works. Because the younger we get our engineers and technologists interested in such youth-inspired research, the much more productive a future that we are enabling for tomorrow. So that's the one thing that I'm so excited about, that my lab is not only serving for the research, but it's also equally putting attention to the teaching and to the innovation and to being all-inclusive, basically. So that is one thing that I'm incredibly grateful for, because Purdue did a lot. Purdue gave me a lot of funding, internal funding, provost office, EVPRP, and Polytechnic, our dean. So I'm grateful to all our leaders for being able to get my research and my motivation of teaching at an equal playing ground at my lab.
EVPRP is the Executive Vice President for Research?
Yes.
Our guest is Gozdem Kilaz, Assistant Professor of Engineering Technology. Just a few months ago, Gozdem, we learned about a research project being led by Professor Linda Wong in Purdue School of Chemical Engineering. She has developed a new chemical conversion process that could transform some kinds of plastic waste into useful products. And you are collaborating with Professor Wong to optimize that conversion process. What products do you hope to convert this plastic waste into?
Well, there is a big broad class of products that we can convert those plastics to, but mostly pristine polymers, clean polymers that can be used as feedstock for multiple products, and of course, liquid transportation fuels, because my lab is able to go ahead and analyze the product stream that Dr. Wang's research team is giving us. And with respect to the specific chemistry that we are observing, we can just give feedback to the reaction just so the parameters can be optimized, tuned with respect to giving us the specific product stream that we need. So I think it's a very good synergy in terms of upstream being very much so connected to the downstream of the process. So we're approaching it as a systems engineering. That's one thing that I love about this project, that we're considering everything and the environmental aspect of it. We're also collaborating with John Sutherland, who is an environmental engineer, and he's helping us with the techno-economic analysis portion of it. So hopefully we will be successful, and we will be giving one option of cleansing the world of all this incredibly large amount of waste plastics that we're currently seeing more and more.
We've certainly seen and read about how plastics being collected in the ocean is such a huge problem. I know we've read some estimates that by, I want to say 2050, there might be more plastic in the ocean than fish.
Absolutely.
So having a chemical conversion process that could convert at least some kinds of plastic right back into usable fuel or other products, it sounds like the solution that everybody's been looking for.
Yes, yes.
Is it possible to explain in layperson's terms how the conversion process works?
It is a high temperature and supercritical water requiring process. What we utilize is, it's very simple. That's the most beautiful thing about Dr. Wang's innovation. We are utilizing supercritical water, which is basically water vapor at a very high temperature, and it is utilized as the catalyst for breaking down the waste plastics so that it can be formed into useful chemicals such as fuel and polymers. So the technology, I think the beauty of the technology lies within its simplicity. But in order to make it optimal, it requires a lot of work, a lot of trial and error, like any other thing that is worthwhile, that requiring a lot of effort. So that's currently what we're focusing on.
That's what it means when you say you're helping to optimize that conversion process.
Exactly, exactly. We're looking at the products that we're getting, and the products being fuels, we cannot just go ahead and apply for the certification without knowing that we are making sure that the main properties of the liquid transportation fuels are met. There are certain regulations that gasoline, diesel, and aviation fuels require, that we should be able to make sure that the product is fitting before we even claim that it is a useful product stream. So that's what we are focusing on currently.
It sounds to me like with the research that Dr. Wang has started, and with the Fuel Lab of Renewable Energy that you started here at Purdue, that it's a match made in heaven.
It really is, absolutely. And on top of all, Dr. Wang is one of my professors from chemical engineering, whom I always admired, not only professionally but personally. She is really a wonderful human being, so it's such an honor for me to be able to collaborate and serve and learn from such an amazing professor, that I am really lucky for this chance.
So what's next for you in your research?
Well, in my research so far, we have accomplished a lot of youth-inspired achievements that I have collaborated with Department of Defense, US Navy specifically, and FAA. And next thing for me is getting back to my roots a little bit, putting some engineering to the game. And thankfully, this is a wonderful news that very recently we were granted by Department of Energy a $1.7 million project that I'm the leader of, that we are indeed going to produce aviation biofuel. So
$1.7 million grant.
$1.7 million, yes.
Congratulations.
Thank you. It's such a beautiful achievement, and I'm so happy for this. We are collaborating with a federal lab, PNNL, and corporate that is currently producing alcohol to jet, which is already an alternative aviation fuel producer company based in Illinois, LanzaTech. So we do have very sturdy players, and we have wonderful colleagues at Purdue that hopefully is going to make a very significant achievement in terms of sustainability. So being able to do this as one of the Purdue member is a great privilege that I take very seriously, and it's a great responsibility that we will hopefully succeed in contributing to the sustainable world.
To use a baseball analogy, when the term of your research is coming, of this grant is finishing, what's a home run?
That we will be able to produce an alternative aviation fuel that brings higher energy content without the production of multiple emissions that the petroleum commensurate would, and
those that contribute to greenhouse gases.
Absolutely, absolutely. And in the meantime, this is a 3-year project. We also are going to try to make sure that the correlations between the chemistry and the properties are better understood, that the ASTM, which is an organization formerly known as American Standards for Testing and Materials, that is going to be aware of how powerful the analytical techniques that my lab is utilizing, which is a comprehensive 2-dimensional gas chromatography, that they will start implementing the chemistry-based testing methodology to their certification process. If we can do that, it's going to be a much better process for all the other candidate alternative aviation fuel producers to have an added incentive to keep on producing more candidates, because the process in itself is not going to be so much of a higher risk anymore, and we will be approaching more and more to sustainable skies.
So let's just take a wider angle view, not so much necessarily about your research specifically. I just want to ask more about you.
Sure.
What's your favorite aspect of your work?
That I can see the products of what we are working on in a shorter term than a fundamental researcher would. And don't get me wrong, John, I have tremendous respect for fundamental research colleagues, because they're working on really very demanding subjects such as cancer, which requires a lot of effort, a lot of long-term work. My research is more of a use-inspired one that we are going to hopefully be able to see how it ends in shorter term. So I like that. I like to have more of a hands-on approach, just like we have in our polytechnic. Our students are the doers, so I would like to be able to see what I am doing and how useful it is in my lifetime, hopefully. So that's one aspect that I really love about my job.
Why do you feel that it's important, especially for young women, girls in high school or even middle school, to consider studying and working in the fields of STEM, science, technology, engineering, and math?
That's a great question, actually. I always say that I will tell you what I always tell my female students. People will see you through your own eyes eventually. So if you see yourself as a productive human being, as a confident person, then I think all the other aspects are just details. Because in my opinion, we are all diverse as is. Even we can be from the same race, same gender, same religion. People innately are diverse. If you look at the siblings, even twins, they are completely different from each other. So this diversity is an incredible gift, and I think we should all welcome it, embrace it, and love it. And for those who are not as blessed to be able to realize this gift, I hope they will see the examples of us who are seeing ourselves as productive, diverse human beings, and then we will just take the world to a much more productive place. And maybe then we can stop sweating the small things and go after bigger, more important things in a collaborative, respectful fashion.
Our Our thanks to Gozdem Kilaz for breaking the news here on Techies Today about her $1.7 million research grant from the Department of Energy. During the past 4 years, Gozdem was named the Outstanding Faculty Member for Discovery, both in Purdue Polytechnic's School of Aviation and Transportation Technology and School of Engineering Technology. Next on Techies Today, we'll visit with Melody Birmingham Bird, president of Duke Energy Indiana, and a 1994 graduate in organizational leadership.
I graduated, walked across the stage, continued across the stage into my U-Haul, where I hitched my red Toyota Celica from West Lafayette to Rochester, New York, to begin my first job working as a supervisor for General Motors with my Polytechnic degree in hand.
Our podcast is produced at Purdue University in Purdue Polytechnic's Office of Marketing Communications. Our college is on Twitter, Facebook, Instagram, and YouTube at Tech Purdue, and the podcast is on Twitter and Instagram at Techies Today. We invite you to contact us via email to techiestoday@purdue.edu. Our executive producer is Melissa Templeton, and I'm John O., editor and producer for the podcast. Thanks for listening. That's what's happening for Techies Today.